We will derive a formula for the derivative of a function that looks like this, x to the power n. So by definition, if I want to find f prime x, then I have to compute the limit as h approaches 0 of f of x plus h minus f of x over h. Now in this case, f of x is x to the n. So I would have to take the nth power of x plus h and subtract x to the n divided by h. Now I'm going to use binomial theorem, and just want to tell you binomial theorem applies only for positive integer exponents. So let's pretend that n is positive integer exponent. Then you can expand x plus h by x to the n plus n choose 1 x to the n minus 1 h plus n choose 2 x to the n minus 2 h square, and so on until you arrive at h to the n. So this is just this expansion, x plus h to the n, and you would subtract x to the n. So the first and last terms cancel each other out, and what happens is every term has h in it. So we can factor an h from each of those terms. And then what happens is, this is just n. So I would have n times x to the n minus 1. And then since this has h square, so I would have something in h. So something in h plus something in h square, and so on. So all of these terms, and in the end, I would have h to the n minus 1. So what I want to do now is plug h equal to 0. Then all of these terms cancel, and I have this formula, nx to the n minus 1. Now, binomial theorem applies when n is positive integer like 3, 4, 5, and so on. But this derivative applies for all real numbers n. They apply to negative integers, it applies to fractions, it applies to irrational numbers. Now we don't have tools to prove that yet, but here is the formula that you can, for now, use it for all exponents n. So if you ever have to find the derivative of, say, x to the 5th, then the formula says move that exponent 5 to the front, and then x to the power, the new exponent is 1 less. So it would be 5x to the 4.